Hi, this presentation introduces the F-OpenMP system, namely a feedback monitoring infrastructure for OpenMP on embedded systems, developed by the Youth Center of Excellence at University of L'Aquila, Italy. A typical cyber-physical system is developed based on knowledge integration from different heterogeneous topics. For example, thinking about the control engine of a car, we have the integration of control theory, algorithm implementations, power and performance constraints related constraints, the last two representing non-functional elements. Focusing on the platform's part that executes algorithms, that in the most cases is an on-chip embedded systems element, having functional and non-functional constraints can drive to the development of strong heterogeneous architectures, composed of different processors connected in a multiple fashion. In this context, considering and monitoring actions can offer support during the entire design time and lifetime of the system. Specifically, it can support the development phases of the system, offering a profiling or a debugging support. Also, it can support during the verification of system status during the life cycle, helping to identify the faults and their causes. In particular, focusing on performance-related constraints, the F-OMP project aims to show how a good customization of the monitoring solution for the platform can offer a great support for developing a multi-thread application on a multi-core system using OpenMP. The considered model of the platform is viewed as constituted of different IOs of elements indicated as I1, I2, and so on, that are managed by a master processing element. The IOs are in general different between them. It is supposed without loss of generality that the IOs are on the NFPGA. Each IO is considered to be composed of general-purpose processors, homogeneous between them, and single-purpose processors representing accelerators. Programming each IO and put all together and working correctly can be a tricky task. By dividing the work in different parts, when allowed by the applications, the task is simplified. For example, consider to have a number of IOs done with SMP systems running an operating system. The performance constraints on them can be reached considering the use of libraries to support the parallelizations, such as pthreads or OpenMP. OpenMP is a library of routines that supports the programming during the parallelization of applications written in C, C++, and Fortran languages. OpenMP offers the possibility to obtain an implicit parallelization using some statements, such as functions and clauses, inserted in the code. It is based on the shared memory model for multiprocessors. During the use of OpenMP, a lot of factors are involved in obtaining a performance speedup for the applications: memory accesses, cache behavior, mutual exclusions operations, and thread balancing. To consider these factors requires some monitoring support during development phases to better understand what is happening at runtime, and how the monitored behaviors are related with the use of OpenMP routines. In an embedded system, the monitoring infrastructure can be required to not interfere with the software execution, or in general to limit the application overhead. In this context, the F-OMP system offers a solution that is based on two concepts. Identify a set of metrics able to support the embedded system designer who wants to use OpenMP to program its platform. Offer a hardware monitoring system infrastructure that does not introduce software overhead, that can be customized depending on metric selections done by the designer. The list of identified metrics is extensive. 3 of them are considered for now: the parallel coverage that gives an estimation about the speed up that can be obtained by monitoring application execution and considering the fraction of effectively parallelized code at runtime. The estimation is based on Hamdan law. load balancing that provides indications on how the work is balanced among threads on processors, false sharing that provides indication about the existence of false sharing problem. The hardware monitoring infrastructure can be customized thanks to the use of reconfigurable platforms. Specifically, in the considered model, starting from the top, there are a series of tasks that can represent without loss of generality the threads that are monitored. There is a series of sniffers that collects events, depend on requested metrics, and put them in event buffers. A group of monitors that represent monitoring tasks running on the master processing elements can use the events to classify them based on selected metrics. A prototype platform has been developed on Zinc 7000 system on chip with the master processing elements represented by dual-core ARM processor and one IO with a 4-core Leon 3 with Linux operating system, where the F-OMP implementation of OpenMP has been provided. A monitoring infrastructure able to provide the three metrics of speed up estimation, load balancing and false sharing is provided. The running application are two OpenMP benchmarks organized to be executed by Leon 3 SMP with data obtained by the master. During the demonstration, it will be shown how to exploit the feedback given by the metrics in order to better use OpenMP clauses for obtaining performance refinement, and how to select among them with a small framework. Thank you.